Interesting bug from Restream, which didn't allow us to share the coding part, the best part. But Adelina almost managed it.
Yeah, I was trying to keep it together.
next time we'll bring a board and a pen, try the code.
Yeah, throw
So
everything. So I'm gonna start from the beginning. We've decided that this is the best approach. So if you joined late or I'll go through it quickly. But you will see my slides in their full glory. So can you see my slides now?
yes, we can.
Okay. Okay, cool. So did it stop sharing? No.
No, it's fine. We can
Okay.
see your slides and video and everything. There's a small delay with like LinkedIn
Okay.
and YouTube, as
Okay,
it
cool.
should, I think.
Sorry, I thought I clicked something. So I'm Adelina, and today we're going to be talking about TDD and Go. And I'm an author and I've written Test Driven Development in Go, published by Pact, which was just recently released. And Nikita invited me here today to talk a little bit more about TDD and how to actually use it in Go. And I'm going to demonstrate this to you with a little bit of live coding, and then I'm going to show you some already written code, and we can have, I hope, a really lovely discussion. One of the things that I also wanted to highlight is that I also serve the community by being a London Gophers and a Women Who Go co-organizer. So this is just like one big shout out for the Go community. And make sure that you get involved with your local meetups. Okay, so I wrote the book with 4 core principles, which you can see here. And I've talked a little bit about them before, but I'm going to share them again now. So, first, writing testable code starts with a thorough understanding of the language that you're writing in. So, in order to write good tests for Go, you need to understand Go. So, throughout the book, I explained some of the fundamentals that you must understand in order to write the code and then actually then write the tests. Another thing that I say is that TDD is hard, not because it's hard to write tests. Tests in Go are just functions like any other function, but because it's hard to have a clear vision of what we're trying to achieve when problems are ambiguous. The third principle is that engineers should take ownership of testing their product at all levels, not just unit level. So what you see here is the testing pyramid, which I think a lot of people are already familiar with. But I just want to say that like the reason why unit tests, why it's called a pyramid, is because unit tests are the most numerous, and then you've got integration tests in the middle and end-to-end tests further up. And I'm going to talk a little bit more about that later. And the fourth thing that I want to say is that, in my opinion, practicing TDD can help you organize your work, keep it simple, really consider the code you're writing instead of just trying to like hammer it out really quickly. And we all know that sometimes we have chaotic days. And I think that if you're really staying in order to, when you're using TDD, then you can really stay focused and actually write code that solves problems, not just getting hung up on a technical solution. I talked a little bit before about the pros and cons of TDD. There are some people that don't like TDD. And I think the pros of having an increased confidence that code changes won't break existing functionality, which is called a regression. And you have also confidence that new functionality will work as intended outweighs the cons. And we can talk a little bit more about writing tests that don't need a lot of maintenance and refactoring. If you write tests that are very focused on implementation, then you are inherently writing brittle code. But if you are writing tests that are very focused on inputs and outputs and expected behavior, then they won't be so brittle and you won't have to maintain them as much. The method that we'll be also demonstrating today is the red-green refactor. So you can see it here. You start and you write a failing test for whatever requirement you're implementing. Then you write just enough code to make that test pass. Then you consider whether you're going to do any refactors, and so on and so forth. This method is often seen as like, oh yeah, it's the method I'm going to use to write unit tests. However, you can use it at any level. Why? Because when you're thinking about the behavior that you're trying to show, when you're, for example, let's say like I'm writing an integration test, I can still write the failing test. Then I will have to write more code to make it green, but that doesn't mean that I can't use the same method. So at the same time, we should consider functional and non-functional tests, because if you have correct code that takes a long time to run or costs a bundle when you're deploying it in the cloud, then it's still not fit for purpose. And the main takeaway that I'm trying to leave you with right now is to test outputs, not implementation. Otherwise, TDD becomes very painful. Okay, so let's leave all that behind and talk about unit testing in Go. So in Go, packages are the smallest unit under test, and they are a self-contained API. And when we kind of like say that as like a throwaway comment, oh yeah, the package API, completely immune to it. But if we think about it, this is very, very powerful. Why? Because tests are the first consumers or clients of our packages and immediately point out code smells. And they also point to us as the engineers what the possible behavior and possible usage of the code we've written is. If we write tests in Go using the testing package, so you see here, the signature of a test is just a function. It starts with the capital test and then followed by a name and takes in a single parameter, the testing.t, which we often name lowercase t. The testing package does not offer any assertions, but it does have different ways that you can fail a test suite. And this is what I'm trying to show in this diagram. And that's why I was like, I hope people can see the diagrams, because I think they really illustrate some things. So the braces show a combination of methods that or functions that are combined as in one single shorthand call. So for example, the difference between t.fail, which you can see here, and t.fail now is that t.fail will fail a test but continue running the suite, while t.fail now will fail the test and stop execution. And then you can log things as well with log, either like logging a message or logging a formatted message. And then when you put these together, so if you want to log and fail but continue executing, then you use t.error. And if you want to log and completely fail the suite, nothing else runs, then you use t.fatal. This was confusing to me in the beginning, so I thought it was worthwhile to point this out. And we also have the testing package also has functionality for skipping tests. Okay, I don't want this to be a whole bunch of chitter chatter with the slides. I just wanted to introduce you to some concepts and then we can get on with it. So in the words of Elvis, a little less conversation, a little more action, please. So now we're going to build a new service. And I've written here what we're going to build. We're going to implement an in-memory employee data store service. So in memory means that I don't have to like do some kind of like crazy storage somewhere else. I'm trying to keep it simple just because, we are working with demo code. It should save employee ID, name, and job title. And it should provide functionality for saving new entries, retrieving entries, and returning meaningful errors. So, what I've written here kind of starts to smell like requirements or expected behaviors. So, we're going to read this and think, okay, this is kind of what I'm going to build. I've talked a little bit about the red green refactor, but this is a more detailed diagram of how the process will work. So we create the test file and test package, then we create the source file and source package, write the test signature, and then continue the definitions. And it seems detailed. I'm going to leave it here for reference, but we are going to practice it together because there's no better time for live coding than right now. So, okay. Oh, another thing that I want to mention is that while we are going to test our new service, we are also going to think about possible test cases. And one thing, when I was writing the book, I learned a lot as well as I was looking through material and coming up with stuff. And I was always kind of like, well, I don't know the difference between an edge case and a corner case. But I think this has now been explained. So an input variable has base cases and edge cases. And in between base cases and edge cases are boundary cases. But when multiple edge cases meet, as you see here, then you have a corner case. And it's really, corner cases are often like things that maybe we could consider not testing, because at one point, writing more and more tests has diminishing results as you approach a higher and higher test coverage. So without further ado, a little more action, please. Okay, so I'm going to step aside from the slides. And I'm going to go over here where I've cloned the repository that I mentioned before. Shall I show it to you? Let me show it to you again. So it's here, github.com. github.com/added/gophertail. You can clone it later. I'm sure we can leave you a link. I don't know if you're interested, but for now, just focus. It's empty anyways because I'm going to write all the code now. So for now, just let's have a look at it together. So what am I trying to do? I'm trying to implement a new employee service, and I'm trying to write tests with TDD. So these are my three things that I'm trying to do together with you right now. So I've created here a new folder called TDD. So the first thing we're going to do is we're going to create another folder that's called data. We can call it something else. But the reason why we create another nested folder is because we are only allowed one package per folder. And this is a thing, constraint that's made by design in Go. So now I'm going to create the test file. So I'm going to call it employees because it's going to be the employee service .go underscore test. Sorry, I said test file and I created the source file. Okay. So now we start to already make some decisions. What should the package name be? So I'm going to call it package employees. Underscore test. That's the first step. I've created the test file and the test package. Now I'm going to create its counterpart, which is going to be the source file. So it's going to be called exactly the same as the test file, just, source employees.go. And then it's going to have the same package. So it's going to be package employees. One is called employees test and one is called employees. So I'm going to do the split screen because I think that'll be a nicer way for me to present it to you. So on the left-hand side, we've got the test code, and on the right-hand side, we have the source code. What's next? What's next is I'm going to create the test signature. So in other languages, like, I have experience with Java. So let's say Java. Um, in other languages, we might do a separate test case for every single scenario. But in Go, we have a different mechanism. So I'm going to call it func test, and I'll demonstrate this to you. Test employees service. I'm going to call it employee service. I've already made now the decision that the structure is going to be called employee service. And it's going to take the test signature, which you see here with testing.t. So at this point, Go will already know that I am writing a test. So I can say that the first thing that I'm going to test is adding new employees, right? So I'm going to do this with a sub test, which you see here with a t.run. And then I'm going to call it add new employee. This is the first functionality that I've decided to test. So a subtest is kind of like a special thing in Go. It allows us to run a scenario or multiple scenarios inside the same test. So for example, now I've said that the main test is called test employee service, and now I'm going to add a new employee. That's great. So now I'm actually going to need to initialize some kind of struct. So in order for the code to compile, I'm going to write the first bit of testing of actual implementation code. So I'm going to now declare the employee service, which we've already said is, we already decided what the name of it was when I wrote the test, employee service, and it's a struct. And I'm not going to put anything inside it. I haven't made any decisions about how we're going to save it. There's nothing else. But I do know that I want to test the add method. So I'm going to declare a method on the employee service, which takes a pointer to the employee service. And the reason that I've already decided to put a pointer is because I know that I'll be adding a new employee, which will be modifying data inside the employee service. I don't know where it's going to be saved, but it's going to have a pointer. And then I'm going to call it add. And it's going to take some kind of parameter. So what parameter should it take? Well, I think it should take an employee payload. So I'm going to go further up and I'm going to create another type called employee. And what did we say that employees should have? They should have an ID, a name, and a job title, which for simplicity, I'm going to make all strings. Cool. So now this add method takes an employee and is going to return a string, which is going to be the ID of the employee. So I've written that in. Yeah. Oh, sorry, I'm shadowing the same E variable, so I'm going to call this ES. So for now, in order to make this compile, we remember Go is a compiled language. So I'm saying this function says I need to return a string and there's no return value. So I'm just going to return the empty string for now. Done. So now this code is compiling. So let's go over and actually do something in the test, right? So what is the expected behavior? I'm going to create an employee. So one thing to notice here is that I've already decided that everything in this, oh, I've mucked this up. Sorry, it's supposed to be called, never mind. I'm just going to call it employees. I was going to name the package data. Because after the name of the I don't like it, to be honest. I'm gonna call it data, sorry. So the reason that I was gonna call it data is because it's after the name of the package of the folder that it's contained in. So I'm gonna call it data in both sides. So I'm gonna call this data, and it's gonna be a data employee. So what happens now is, what is data? I have no idea what data is. This is because the package these are two different packages. So everything that I want to test from the data package needs to be exported in order for us to have access to it in the test package. This is why I said before that tests are the first consumers of the package API. So I need to import it just like any other package. So the path for it will be, I'm going to write it manually just to demonstrate. The path for it will be the Gopher tail GitHub, exactly what I've got here. So in order to see what you've got, so this is called, I'm going to show you exactly how like packages really work in Go as well. So we start with the module name. So that's the module name. And then we go to TDD, which is the name of the folders that we've got here. And then we import data. And then voila, we now know exactly where the data is. So inside the employee, we're now going to put some data. So we need an ID. So the ID is, they're all strings. So it's going to be A1. The name is going to be Nikita because we're on Nikita's stream. And his job title is going to be the boss of everything. So now we have our first data input. What should we do next? We need to create an employee service, which is the unit under test. So I'm going to call it ES, and it's going to be called data.employee service. Cool. And then now we can say like this, now I'm going to invoke the method that I actually want to test. So it's going to be es.add, and I want to send the employee payload to it. And I'm expecting, and it's going to return an actual ID because that's what the signature we've decided will be. And now I want this ID. So actually, I was thinking to use the Testify assertion framework to make the code simpler. But because we spoke a whole bunch about errors and the testing framework, so now I'm going to use the actual inbuilt testing framework. So I'm going to say if ID does not equal to e.id, which is the input that we've sent, then I want t.fatal. Yeah, and then I'm gonna say goodbye. So we can format. Actually, no. So the way we do it is like we say got. So usually, if we're gonna format a string, we use it with the FMT package. So usually we say got whatever, want something else. And then I'm going to pass to it so I got the ID and I want the employee.id. Okay, so this is our first test. Not too bad. It's quite simple, actually, if we think about it. So time to run it and see it fail, right? Because that was the whole thing. I want to write this test for a requirement. Everything is compiling, and now I want to see it fail because otherwise I'm not doing red green refactor. Otherwise I'm just like talking to a camera and writing code, right? So what I'm going to do is I'm going to cd inside the TDD folder just so it's easier. And then the way we run tests in Go is with the go test command. And then these three ellipses say detect all tests and run them. And -v is the verbose flag because I want to see what's going on. So what's happened is I failed the test. Okay. So, oh yeah, here, sorry. I was looking where my output was. So we got empty, but I wanted a 1. That's great because actually it's returning empty because I didn't implement anything. So let's now implement something. So the next thing I'm going to do is, in order for us to implement a storage, we need to decide what to store. So inside the employee service, I'm going to create a map. The reason why I'm going to opt for a map is because I explained earlier in our requirements that I want to be able to fetch employees by ID later. So inside the employee service, I'm going to declare a structure called data, which is a map of string to employee. Done. But now it's saying, well, data is not used. So in Go, we're not allowed to have like unused variables or fields. So it's time for us to actually use it. So inside the add function, I'm going to say data. Es.data, exactly like it says. And then I'm going to add the by ID. So the key is the ID, and the value will be the employee. And then in the return, I will return e.id, which should be kind of what we wanted, I'm hoping. So let's run the test again. Actually, before I run it, let me clear the console because I want you to see the output better. Let me see here, go test. Oops, minus verbose. Oh, something really bad happened. So what happened is that I'm trying to assign something and write it to this data map, but but the map itself has not been initialized. I was pretending like I didn't know this was going to happen, but yeah, I did know it was going to happen. So the zero value of a map is nil. So I'm trying to write something to nil. So what we need to now do, I have two options now. I can try to initialize the data inside the test, but it hasn't been exposed. So I actually don't have access to the map itself here. And the reason I decided not to export it is because I don't want code outside of the data package to modify the data without me knowing. And that was another decision that we made while we were implementing it. So the way that I'm going to fix it is by creating a new function. So structs don't have constructors. What we do is we create our own new function.
Hi, Adelina, there's a question
Yeah, go for it.
from LinkedIn. Is it a good practice to move the instruction in line 17 out of test employee service function?
We
Or
can
is it
we can put it further up. So I think what they're saying is to add it all the way up here so that it can be used by multiple tests. Is that the question?
yeah, I think that was the question.
Yeah, but right now I'm going to leave it in there because I don't want these tests to share state always. So most of the time I actually advocate for keeping the scope of your test, of your unit under test, as small as possible. But if you are not persisting any data and not making any changes, then yes, you could share the unit under test between multiple scenarios or subtests. Okay, so I'm going to continue. So I'm going to now create a new employee service. There's too many E's in employee. So this function is going to be exported. Why? Because I want anyone who uses the employee service to use it to instantiate the employee service. So this is going to take no parameters, but it will return a pointer to an employee service type. So inside here, I'm going to take care of this pesky nil map. So I'm going to return a pointer to an employee service. And the way we initialize maps is with the make function. Oh, I thought I was making make. Is with the make function. And in now we will have an empty map to write to as opposed to nil. The last thing to do is now to go here and make use of the actual function, and then we won't have nil maps in our test. So, okay, now I've created a new employee service. Let's try and run it again and see what happens. The test is passing. Excellent, excellent, excellent. But one other thing that I might want to do is I might want to do some kind of validation, right? So I'm going to decide that I don't want to refactor this in any way because my code is perfect. But, at this point, you could enter the refactor stage. But one other thing I want to demonstrate to you is let's say that I want to do some kind of validation on the add employee function. So for example, I might want to make sure that employees don't have empty names. So let's see how that would work. The first thing I want to do is I want to change the signature of this test to be able to return an error. So usually we return a pointer and then an error. So in Go, you can have multiple return values, and the inbuilt error type is how we return something going wrong. So in this case, I'm going to return nil because I haven't done anything here. And the reason why we put a pointer to a string is because in case something goes wrong, I want to make it very clear to whoever called me that you cannot use this value. If I return an empty string, they might be inclined to use it. If I return like invalid, then I'll have to check against this invalid value all over my code. So usually we return a nil. And now I need to change this to make sure that it's a pointer as well. I'm going to go back here and do a refactor to my test. And I need to handle the return value. So what I'm going to do is I'm going to get an error. And in the case that, so I'm going to, let me just copy this actually, it will be easier. Yeah, so in the case that the error is not nil, then I want to fail the test as well, right? Because like, what am I supposed to do now? If the error is not nil, then I can say unexpected error and yeah, unexpected error, and just simply return the formatted error. Ooh, too many R's. Now here I need to dereference the ID. Oh, sorry. I need to dereference it here as well. And then this needs to be formatted. Okay, all good. The reason why this is a safety reference, so in the case that an error had occurred, then I know that I'm going to get a nil. So I'm going to fail the entire suite and I won't continue. But because I've checked the error first, I know that by the time I reach line 22, this ID is safe to dereference. So that's like one thing that we always do in Go is we test that the errors, we test that we check for errors first. Okay, so now I'm going to write a new test case that actually checks an error has occurred. So the way we're going to do it, just because I'm short on time, is I'm going to duplicate this and then we're going to talk a little bit about code reuse, which I think was one of the questions from earlier. So I'm going to create invalid name employee. This is what I'm going to call it, add empty name employee. I'm still going to create a new employee service. But this time, I'm not going to give it a name. So I'm going to remove Nikita. So this is the invalid input that I will be sending down. Okay, so now I will be expecting an error to happen. So I'm going to say that the error must be nil. Error not occurred. So if the error is nil at this point, then actually no, I'm going to do something else. Sorry. So the ID has to be nil at this point. So I can say unexpected non-nil ID.
So is it like a negative test? You're trying to see that
Yeah,
the code
sorry.
will
Yeah,
break
so
when it should.
yeah, exactly. So sorry, I've got this all wrong. So at this point, I want the ID to be nil. So if it's not nil, then the test fails. So I'm going to say the unexpected non-nil ID, and then it's going to have the value that I was actually returned from it as well. Now, if the error equals nil, if the error does not equal to whatever error I want. So now I'm going to decide what kind of error I actually want. So I'm going to call it errors. It's actually hard for me to say the double R's because of my accent, but yeah, it's errors. So I want to say the error should be, the error string should be empty name. I don't know. I'm just coming up with something. So if error is nil, sorry, yeah, or the error value is not empty name, then I'm gonna say got, and I wanted something else. So I got the error, but I wanted errors on new. Okay, so let me just quickly explain this again. I think all of a sudden I'm out of space. So in the case, as we're writing these assertions, we write assertions for what's going wrong. As you pointed out, Nikita, it's negative stuff. So if things are not as expected, I'm looking for reasons to fail the test. So in the case that the ID is not nil, then I can say that, okay, this is failed. So I'm saying an unexpected non-nil ID. If the error is nil, or the error message is not as expected, then I'm going to fail this test as well. So there's two things that I'm asserting on now. Does that make sense? I'm going to
Yep.
take silence as compliance.
No,
So
it does.
yeah, so I'm going to clear, and then we're going to run it. And hopefully something bad will happen, because I'm clearly not. Yeah, so I'm expecting non-nil ID, but I returned A1. So the reason is because I don't have this empty, the employee with the empty name was actually successfully saved because I haven't implemented any error handling. So now it's time to actually make the test pass. We remember that. So if e dot name is empty, I'm just going to say it's empty. So again, in Go, we're doing, again, in Go, we're doing error cases. So it's always like, what's bad? Check whether the bad thing is happening, and then stop execution. So if the name is empty, then I'm going to return nil, because that's what we said. In the case that something bad happens, I want to give you a fully unusable value. And then I'm going to return a new error. So the way we initialize errors is in a few ways, but in this case, I'm going to say that it's empty name. I'm going to use the errors.new, and then I'm going to put the empty name. So, and at this point, you can pass an ID. You can make this error more explicit about what's going on, but I'm going to stop here. So I'm going to clear my console, and then hopefully this should pass, and it passed. I don't know why I'm so excited. I knew what was going to happen. Cool. So I want to talk a little bit about code reuse in tests. So we've already discussed that I'm doing a lot of the same. So I'm doing a whole bunch of initialization of inputs. So what people often do is they write something called table-driven tests. And table-driven tests in Go, I haven't prepared to show you that because I think we're already running a little bit low on time, and I want to show you some other stuff as well. But table-driven tests allow us to kind of uh, extract the same initialization code, run the same assertions, and just a for loop over different inputs and expected outputs. And there's a lot of blog posts out there where you can see how to do that. So don't worry about me not demonstrating it right now. One of the things that I really wanted to demonstrate was the implementation of TDD and Go and how we're swapping between like the changing of code and then writing new test cases. So that's the end of this. I had prepared to do more like live coding, but I think this is already a good demonstration. So I'm going to leave it for now. Another thing that we will implement is we should implement is the get function, because I said that we wanted to fetch employees as well. But I will commit that on the repository and then you'll be able to see it. So for now, you're going to have to take my word for it. Another thing that I really wanted to talk about today, because I said your responsibility is not just unit testing, and then I went and I showed you a unit test, right? Is I wanted to talk a little bit about integration testing. So there's a lot of talks at different conferences that talk about integration tests being great. Why? Because they allow us to cover the test to write tests that cover multiple components, while not having to start the full application and run tests over the entire stack. So integration tests cover one or multiple components, ensuring that they work well together, while unit tests are very focused on one thing. And a lot of bugs happen not only because something is incorrectly implemented, but because it's not compatible with its other thing or it's not returning something that's expected to the caller. And they have the advantage that they allow us to have the bigger scope while not being as slow as end-to-end tests. So what we see here is that unit tests are fastest. So they have the fastest feedback loop, which is like what you saw me using. And this is why we use them to write code. Then you have integration tests, which are less fast, but allow us to cover more. And then you have end-to-end tests at the very top, and they should be used only as required because it's harder. If they do fail, it's harder to tell what in the name of God failed. And then it's also harder to replicate stuff. So integration tests, I did a little brief comparison of integration tests versus end-to-end tests. So integration tests can be performed early. They're faster and cheaper, and they allow us to test integration with external as well as internal modules. So even if in the world of microservices, even if you have a service that like belongs to your company, it might be implemented by a different team, and you don't always have the control of what that team is doing. They could be breaking APIs, or maybe you missed a meeting and they discussed this change and it was approved, but actually you're unprepared for it. So anything that is outside of your service in your control, you can kind of like consider as an external dependency. And then end-to-end tests are performed at the end of the development process when the product is complete, so usually much later. They're slower and possibly expensive, but they are very, very useful for testing user flow and experience. Not so much for like testing integration. So I wonder if there's like a better way to do it. And in Go, there is. So this is going to be the second part where I'm going to demonstrate to you some code. I won't write it from scratch because you'll see it's quite verbose. But I'm just going to show you what it is. So we're now going to take our implemented data storage employee service and make it do web stuff. So we're going to expose the data through two endpoints. We're going to do get employee by ID. I did just like a URL parameter here. It doesn't really matter. And then we're going to post a new employee to the employee's endpoint, and that should create it. In Go, we have this utility, which is called HTTP test. It's just its own package that makes it really easy to test HTTP endpoints. So the HTTP handlers. So I wanted to take a little bit of time and show you how that looks. And it makes integration tests really a breeze. So I'm gonna create some files, and then I'm gonna put some code in there from my already completed solution, and then we'll discuss it. So first, I'm gonna create a new folder, and it's gonna be called handlers. And the reason why we need the new folder is because the handlers are gonna have their own package. So I'm gonna close everything for now. We're not gonna do the dual thing anymore. And now I'm going to create a new file, which is going to be handlers.go. So I'm going to paste the 2 seconds. I'm going to paste the source code first, even though you shouldn't. You should use you should use TDD. So you've got employee. Oh, I didn't implement the get because I didn't have time, but it doesn't matter. We're not gonna. I'm gonna fix that in a moment, and then we're gonna do a handlers test as well. And then I will talk you through it. So, we're gonna use this. Handlers underscore test. Go. Okay. And then just because it really irks me to see that we don't have that stuff is not compiling, I'm just going to put the get function in the employee service so everything starts to compile. But it doesn't matter, I told you. Okay. So let's see what's going on here. Yeah, so in this one, I'm actually using Testify, which is an assertion library, but it doesn't really matter. Okay, everything's compiling. Let's have a look at it. So in the handlers, I've created, let's look at the simpler one, which is getting an employee by ID. So I get a URL parameter, which is the ID. If the ID is empty, I return an error. Otherwise, I pass it to the data service. And then if it's returned successfully, then I return this to the employee. Then I write this to the response, and then I return this. So when it comes to testing this is kind of a nightmare, right? Like, look, I have to test headers. I have to think about like JSON encoding. There's a whole bunch of stuff. There's HTTP statuses. There's a whole bunch of stuff that needs to be tested here. So I would be kind of like, well, and even then, I don't know for sure like how it's going to work. So this is a great example of using an integration test. So I want to make sure that the handler is calling the correct service underneath, and that the expected format is returned. And the way we're going to do that is with the HTTP test library. So we're importing it here. So it's net HTTP test. So what we do here, so skip this for a little bit because I'll explain this in a little bit. We do exactly the same thing as before. It's to test like any other, the same test signature, nothing special. Then we create an employee, and this is where the real magic happens. We use the HTTP test package to start a temporary new server that uses the same handler function that I've just defined, and it starts up. And then inside the actual test, all we will get the server URL, create the path that we want to test on, and then we can actually do assertions on the response as it is. So this is super, super powerful. The HTTP test package starts up, uses the handler, exposes a path, and then we can actually use it like as expected. This is crazy. It's almost like running an actual end-to-end test, but just really fast. So the reason why I did this at the top is because when you're running a unit test suite, you expect unit tests to run. You don't expect slightly slower, okay, fine. You don't expect integration tests to run. So there are a few ways you can do that, but the way I've done it is with an environment variable. So if I set this long environment variable, then I am telling it, hey, run the integration tests as well. So the way that looks is, now I've put in all the tests. So now I'm gonna run this. And what you see here is that the integration tests now by default are skipped. And this is the expected behavior. When I write go test, I'm expecting unit tests to be tested, right? But the way I would now run all of the tests is to add the variable. So I can add the variable, it can be anything. I'm going to put it to true. Is to add the variable at the beginning of the command, and then this variable will only persist while the command is running. So now what you can see is that I'm actually running the integration tests as well, and this is easy peasy and really useful, and it's a really useful way to run it locally as well as in your CI/CD pipelines. So that was the little magic with the environment variables at the top. If you are writing, a lot of the usage of Go is to write web stuff and to implement handlers. So definitely, and I think this is really a top tip. So definitely, if you're going to be writing this kind of code, remember to use the HTTP test package to test its integration. So that's the end of what I wanted to show you. I'm going to go back to my slides and do just a very, very quick summary. So I want you to remember that writing tests is not hard, but knowing what the test is. And you should always start from a place of clarity. Before your fingers touch the keyboard, you should understand what you're building, why you're building it, and then you can start to formulate a direction in which you're going to implement it. It's happened to me in the past where people were talking to me about what we're going to build, and I was already thinking about the code I was going to write. You should try and stop this kind of way of thinking. Really try to immerse yourself in what you're building. The Go package is the unit under test, which we saw when I did my demonstration as well. And you should always use an underscore test package, so the external test package, to ensure you're testing only the exported functionality. This will make it easier for you to really understand, what am I exposing, what behaviors can people who are using my package, what behaviors can they leverage. Another thing is that integration tests are a great way to extend the scope without losing some of the performance. And integration tests are also a great way to really make sure that the code you write works well together, not just individually. And lots more concepts are covered in the book. I can come back and give you more of the advanced stuff if you wanted to. So one of the cool things that I was thinking about demonstrating is contract testing, but contract testing allows us to test actual like integrations between two services by it itself, like the contract testing framework called pact, creating mocks in between it, and passing contracts around. Anyways, you can read more about it, but I decided to go with an introductory session, so that we really understand, the base stuff before we go complex. So again, thank you so much for your time. As I've referenced Elvis multiple times, I wanted to say thank you very much, and thanks for spending this almost 1.5 hours with me. You can reach out to me on the socials, and then I'm gonna commit the codes we wrote today together. So yeah, that's all I've got for you today.
So, a few questions.
Oh yeah, why didn't you say?
No, I always have questions because I can start asking, like, because I'm not a Golang developer, I can start asking with like, what is the package? But that's fine. So first question, can you show your book on Amazon? Can you
Yeah.
share the page?
Yeah, sorry. Let me just find it quickly and then I'll share my screen again because we can do that now.
Yeah, because basically the whole point of the book is that it's teaching Go TDD way,
Yeah.
and that's a great step, and that's actually an idea for everybody listening now or later. That if you want to create some content, teach people how to learn a language by doing TDD,
This,
because
you
normally,
wanted this, right? Yeah.
yeah, yeah, that's the one.
Yeah.
So you can find it both on American Amazon and UK. And the other question was, can you show your GitHub repository? Because
Yeah.
the link was in the bottom and it was covered by.
Oh, sorry about that. Yeah, of
No, it's
course.
fine. I shared the link, but I just wanted people to be
Oh, I
aware of
haven't.
it.
I've only shared one tab. Let me stop sharing again. Sharing is fun. Here you go.
Okay. Yeah,
It's
that's the
Let's go for tail. Um, but I'll share a link to the slides so you can have the lovely diagrams. You can copy them, do whatever you want with them, and then I'll share a link to this as well. Is that good?
yeah. Yeah, it's good. I've added the link as as an idea to everybody listening. What you could do, for example, besides getting the book and trying all this cool stuff, you could go, for example, to Exercism.io and create your own exercises there and get a
Yeah.
ton of points as well. This is one of the best ways, because the problem with TDD is that normally people learn how to code first, and they learn how to code complicated stuff, and then somebody shows them quickly how to code a calculator, and then they start asking why it's not 100% coverage and why there is no integration test, because
Yeah.
um, nobody thought of Docker or HTTP servers being brought up as a part of a code test.
Yeah, so this repository is why I kept the Gopher Tail repository. It also has the code we wrote for the concurrency stream. Um, so people can have, it's going to be in the fundamentals, and then there's going to be a repository. So yeah, inside here is all the demo that we did with the monsters and the heroes, remember? Um,
Yep.
yeah, and then if you already want to see it, I haven't merged it because I wanted to do the live coding, right? But if I go back here, yeah, so there's branches here, and one of the branches is called TDD solution. So you can see everything I've written here. It's already here. So people can already use the branch if you wanted to. I'm gonna go and commit it very soon.
Thank you. Imran Hashdeep, any questions?
Yes. Hello, Adelina. Hello, Nikita. And hello, Harshdeep. So my question is like I've just started learning Go. Like it's been 10 to 12 days. I'm a beginner in programming and coding. So what are the practices to like add learn TDD as well? Like as I'm learning Go, and so that I can learn TDD as well. Both of them together.
Yeah, so actually, as I wrote Java before, right? So actually, one of the reasons I decided to write this book was because I thought it was really difficult to get into like the Go way of writing tests. Like, where's my mocker? Where's JUnit? I don't know if there's anyone who writes Java, but like Java tests are very different. Um, so I think as you're starting to write any code, think about your test code just as like your source code, because I told you it's just the functions, but they simply use this testing library, this testing package that's inside the standard library anyways. So definitely look into table driven tests, because I didn't demonstrate that, but it allows you, it's like more or less practice and how to and the way people do tests. I don't think they're suitable for everything, but as you start to look into it, you'll learn. And then I think a lot of it will be trying to build things. So try to build a bot, do some kind of integration with GitHub. I think this kind of tools would be cool to build. I wanted, so you see behind me, there's a Peloton. So I wanted to build like dashboards for my Peloton workouts, but I haven't had the time. If I start the project, I'll invite you and we can build them together.
That's great. I have more questions, but Hashdeep, maybe you have questions.
Yeah, I've got time. I mean,
So okay, while Hashdeep is collecting thoughts, so first question is, what is your favorite way of learning? What is your favorite resource for learning Go? Like, is it exorcism? Is it some code cutters place?
so when I learned Go, I read books. So I've read a lot and I like did the exercises. So there's like the Go language fundamentals, or I don't forget the name. I forget the name of it. It's like the Go language fundamentals. There's like a book about applied concurrency in Go. Now there's like 100 Go mistakes and how to avoid them. I do think also, so mostly I read things, but I think it's also because like, you know, I'm a little bit older. I think the newer generation like more video content. Um yeah, don't tell anyone. But yeah, that's kind of how I learned it. One of the things that I really like is when you have the code on paper, you can kind of like really look at it, really absorb it. And when I first started out, I didn't copy paste any code. So I wrote everything from scratch, because you saw you end up in a mess. Even now, when I was doing it, oh, I named the package wrong, stuff like that. It's important to really understand every single thing that goes in your file. Yeah, that's probably another thing about like getting started. Try to write it from scratch. It'll give you a really good understanding of how to integrate with the standard library. And when you don't understand it, you can just like click through, and the Go compiler is then the Go standard library, sorry, not compiler, the Go standard library is open source anyway, so you can see what's happening.
That's interesting, especially about paper books. Now I'm thinking maybe that's why I still have space to develop, because I was always reading from the screen. You also created a number of courses on Go on LinkedIn. So can you talk like which area they cover?
Yeah, so my first one was about concurrency. And then, so actually let me share one thing. It'll be on my blog, where people can go, and if they click on the links that I shared there, you can take the courses for free. So let me just share. So if I put something in the chat? Is that possible? I don't know how to write chats. Okay, there's only this private chat, so I'm gonna put the link there.
I think you should have on there, right? Okay, I'll put the link.
You
I'll
put
just
the
copy
link,
it.
please.
Yeah, I'll put it there.
I've got a million
Yeah,
problems
must work.
today. Yeah. So if I share this, so the book is here and there's a link to it. What here there's my instructor page, which has, oh, you can't see that, but my instructor page has the 3 courses, and if you click these links you'll be able to take the courses for free. So the first one is applied concurrency in Go, which was my first one and it is the most advanced one, so I went the other way around. The second one is transitioning from Java to Go, so it was all about like explaining stuff from the more fundamentals, and I draw parallels to Java, but you don't need to know Java to take it. And then the last one is code challenges, so it's called Level Up Go. And this one runs in code spaces, which is particularly useful if you don't want to install anything. But in all of them, I explain the fundamentals that you need to know before you do a challenge. Yeah. If these links, I want to say that if these links don't work for anyone for any reason, message me and I'll send you the free link. Yep.
Thank you.
So
That's
definitely, I want to.
amazing gift.
Yeah, I definitely
Oh.
want to.
Yeah, so that's
Yes.
the page.
Yeah, I definitely want to make it available to you to take for free. So that's all.
Okay, good. Any more questions?
Also, that's my blog, but that's where I put the links, so I have them.
Yes, and I'll show the
GitHub.
Oh,
very nice captioning now.
Yeah, I just want one more
overlay.
functionality. Yeah, I still want to speak to the stream people about today.
I think we managed quite well.
Well, we did, yeah.
I hope that people found it useful. It's always difficult to gauge what people expect, but yeah, I try my best. I hope it was useful.
Good, you did well. So let's catch up later. And by the way, when I click end stream, we still can talk.
Okay.
And streaming. So
all right, well, everyone, thank you so much, and don't hesitate to write to me if you've got any questions. And yeah, good luck with your learning. Thank you so much.
Okay, so we're ending stream, but we can stay here and talk. Bye, everybody.
Bye.
So this